All right, picture this. You have to schedule hundreds of university professors for hundreds of different exams. Sounds kind of simple, right? Well, it turns out it's a total logistical nightmare. And it's the perfect kind of puzzle for AI to solve. So today, let's dive in and see how artificial intelligence is untangling the surprisingly complex real-world problem. So let's set the scene here. Every university has final exams, and, every single exam needs someone there to supervise it. The big challenge is getting all those faculty members organized to cover hundreds of different exam slots. I mean, really think about that for a second. It's way more than just plugging names into slots. You've got to think about who's available and when, what other duties they have, and you have to make sure the workload is spread out fairly. It's this massive juggling act, and if you drop even one ball, the whole thing can just fall apart. And this job, it has an official name, invigilation. It's an absolutely crucial part of making sure exams are fair and that there's no cheating. But you can probably guess, coordinating it has always been a massive headache for the people in charge. So before AI jumped into the ring, how did they handle this mess? Well, they used the tool we all know and occasionally love, the shared spreadsheets. But for a job this complicated, it was causing some really serious problems. To give you a sense of the scale here, just look at this number. For a single exam period, coordinators would get somewhere between 450 and 500 offers from professors saying, "Hey, I'm available these times." Now that sounds like more than enough people, right? But it actually created a whole new kind of problem.
See, the university only needed to fill about 150 of these duties. So you've got 3 times more volunteers than you actually need, which should make things a piece of cake. But it doesn't. The issue is that pretty much everyone volunteers for the same popular easy dates, leaving the other days totally empty. And this mismatch is exactly where the manual mess really began.
The result was just chaos. I mean, with a shared spreadsheet, you had data getting deleted or changed by accident all the time. People would pile onto the easy days, which meant you had critical shortages on the unpopular ones. And on top of all that, coordinators had to manually check for every single little scheduling conflict. It was just a recipe for mistakes and so much wasted time. And that really gets to the heart of the matter, the human cost. This quote from the source material says it all. We're talking about hours and hours of really tedious manual work with someone trying to piece this puzzle together, all while knowing that the risk of making a mistake was incredibly high. But what if you could take that entire manual mess and just hand it over to a system that's literally built to solve these kinds of puzzles? Well, that's exactly where this intelligent, automated solution comes into play. And the change is just night and day. On one hand, you've got the old way, tangled, manual, slow, and full of errors. And on the other, you have a new system that automates the whole thing, optimizes it for the best possible schedule, and makes the entire process unbelievably efficient. Now, the technology that powers this is a field called operations research. And hey, don't let the name scare you. The absolute best way to think about it is as the science of puzzle solving. It uses math and smart algorithms to find the perfect solution out of countless possibilities, which, as you can imagine, is perfect for a scheduling problem like this one. So how does this thing actually work? Well, it's a pretty straightforward 4-step process. First, it gathers everyone's availability, just like the old spreadsheet did. But then, this is where the intelligence really kicks in. It checks all the rules, like who's qualified for what duty, it automatically spots any conflicts, and then finally it crunches all the numbers to create the most balanced, complete, and fair schedule it possibly can. The impact of this new system is, frankly, huge, and we can break it down into 4 key areas, or what we can call the 4 pillars of improvement. These benefits really boil down to 4 main things: efficiency, fairness, transparency, and reliability. This AI system doesn't just make things faster, it makes the entire process fundamentally better, and more importantly, more trustworthy for everyone. Okay, first up, efficiency. The amount of time that coordinators had to spend on this task just plummets. We're going from hours of painful manual work down to mere minutes. That time saved lets them focus on things that actually require a human touch. And then there's fairness and reliability. Because the system can see the entire puzzle all at once, it distributes the duties evenly. No more overloading some people while others get all the good slots. It creates a schedule that not only works, but one that everybody can actually trust is fair. So what's the big takeaway from all this? Well, it's not just about one university's exam schedule. It's really about a fundamentally smarter way of working. Yeah, this system is basically a blueprint. Think about it. Nurse scheduling in hospitals, rostering pilots for an airline, or planning delivery routes for a logistics company. These are all incredibly complex puzzles that can be solved way more effectively with intelligent automation. You reduce errors, you save time, and you make work better for everyone involved. And that really leaves us with one final thought. This technology solved a huge, frustrating puzzle for a university. So what other hidden, time-consuming puzzles are lurking in our own work lives, just waiting for a similar, intelligent solution to come along? The possibilities, when you think about it, are pretty much endless.
Now I will demonstrate how the application works from the faculty user perspective. To begin with, the user first needs to navigate to the User View section of the portal. From there, the user selects the willingness area, where faculty members can submit their availability for invigilation duties. Before accessing the calendar interface, the user first selects their name from a drop-down list containing all faculty members in the department. This drop-down menu includes the complete list of faculty members from the School of Mechanical Engineering. For example, here I am selecting Dr. V. M. Srihri from the list. Once the faculty member is selected, the system automatically retrieves the corresponding designation details, duty requirements, and relevant scheduling constraints associated with that faculty member. After this selection, the system loads the interactive examination calendar, where the faculty member can proceed to provide their willingness for invigilation duties. The calendar is carefully designed to prevent scheduling conflicts. The dates that already have fixed valuation duties are automatically locked, which means faculty members cannot select those dates for invigilation duty. This ensures that conflicts between valuation duties and invigilation duties are prevented at the willingness stage itself. In the calendar interface, we can see blue-colored numbers displayed on each date. These blue numbers represent the number of invigilation duty slots required by the Controller of Examinations office for that particular examination day. Each day typically contains 2 examination sessions, FN, forenoon session and afternoon session. The blue-colored numbers indicate how many invigilators are required for each session on that day. This provides faculty members with a clear visual understanding of where invigilation duties are required across the examination schedule, helping them plan their willingness more effectively. The system also displays important information related to the selected faculty member, including the designation of the faculty member, the number of duties that need to be allotted, the minimum number of willingness entries required. This helps guide the faculty member in providing sufficient availability across the exam schedule. Before selecting the dates, the system also provides guidance on how the duty allotment will be determined by the optimizer. Here we can see the section titled, How Your Duty Will Be Allotted. This section explains the possible ways in which the system may assign invigilation duties based on the submitted willingness and scheduling constraints. The first category is exact match, where the duty is allotted on the exact date and session selected by the faculty member. The next category is session adjusted, where the duty may be assigned on the same date, but the session may be swapped between forenoon and afternoon if required. The third category is date adjusted, where the duty may be shifted within plus or minus 1 working day from the selected date in order to satisfy slot requirements. Another possibility is valuation adjacent, where the duty may be assigned on the day before or after a valuation duty, while still ensuring that scheduling conflicts are avoided. Finally, in certain situations, the system may perform a system-assigned allocation, where a duty is assigned even without a direct willingness match in order to ensure that all invigilation slots required by the examination office are fulfilled. The system also encourages faculty members to spread their willingness dates across the examination period, which increases the likelihood of achieving an exact match during allocation. Now I will demonstrate how the faculty member selects a specific date. For example, here we can see the date 14th May, 2025, which is a Wednesday. For this date, the system displays 2 examination sessions, FN, forenoon session and afternoon session. For each session, the system shows additional details including the number of invigilation seats required, the number of faculty members who have already applied a dynamic allocation probability indicator. Since the willingness entries from other faculty members have already been collected and uploaded by the administrator, the values shown here represent the current likelihood of allocation based on the number of applicants and available duty slots. This dynamic probability continuously updates depending on how many faculty members have already applied for that session. The probability is calculated based on the ratio between the available seats and the number of applicants for that particular session. This feature helps faculty members identify sessions with higher availability and make informed decisions while selecting their willingness, which improves the chances of achieving an exact match during duty allocation. Once the required number of dates is selected, the Willingness tab becomes enabled, allowing the faculty member to submit their availability. After submission, the willingness information is stored securely in the system database. At this stage, if the faculty member navigates to the allotment section, the system will display a message indicating that the duty allocation is still under processing. The page shows the message, "Allotment results are being processed." Along with this, the system displays a note stating, "The examination committee is reviewing the final allocation. Please check back shortly." This indicates that the willingness data submitted by all faculty members is currently being reviewed and prepared for the optimization and duty allocation process. Now I will switch to the administrator view. After collecting the willingness from faculty members, the administrator can view the overall system summary in the admin dashboard. Here we can see the key statistics of the collected data. The system shows the total number of faculty members, which in this case is 70. Out of these, 70 out of 70 faculty members have successfully submitted their willingness, confirming that all required faculty inputs have been received. The system also displays the total number of willingness rows collected, which represents all individual date selections made by faculty members. In this case, there are 478 willingness entries spread across the examination schedule. The dashboard also indicates the active optimization solver currently being used. At the moment, the system is using the SEIPY solver as a fallback option, and it recommends installing Google Or tools for improved optimization performance. Next, before running the optimizer, the system performs a pre-run diagnostic check. This diagnostic verifies that the willingness data aligns properly with the exam schedule. For example, we can see that the number of slot dates defined in the exam schedule is 38. The number of willingness dates submitted by faculty is also 38. This indicates that the willingness data correctly overlaps with the available examination slots. The system confirms this with a successful overlap indicator, ensuring that the optimizer has valid input data to proceed. This step also ensures that all faculty members have provided their willingness before running the scheduling algorithm. Now the administrator proceeds to run the optimizer. The optimizer processes the collected willingness data and generates the invigilation duty schedule based on the defined constraints. Once the optimizer completes its execution, the system immediately displays the overall allocation results of the optimization process.
After verifying these results, the administrator can proceed to the View Results tab. In this section, the system provides additional analytical reports including faculty summary per faculty deviation analysis willingness match and deviation full allocation table. The full allocation table can also be downloaded and shared with the Controller of Examinations Office for official records and further processing. Before making the results visible to faculty members, the administrator can manage access through the portal settings section. Here we can see the setting titled Allotment View User Access Control. This control allows the administrator to disable the allotment view while the optimization process is running or while the results are being reviewed. When this option is disabled, the portal displays the message, Allotment View is disabled. Faculty see a waiting message. In this state, faculty members who navigate to the allotment section will only see a processing or waiting notification, ensuring that incomplete or unverified allocations are not displayed. Once the examination committee has reviewed and approved the final duty allocation, the administrator can enable the allotment view. After enabling this option, the final duty schedule becomes visible to faculty members in the allotment view section. Now when faculty members navigate to the allotment view, they will be able to see their assigned responsibilities, including invigilation, duties valuation, duties final duty allotment, details question, paper, responsibilities feedback information. Faculty members can also receive their duty details through WhatsApp by entering their mobile number, which serves as a convenient reminder for their scheduled duties. Through this system, the manual and time-consuming invigilation duty allocation process is transformed into an automated, transparent, and efficient digital workflow. By integrating Python, artificial intelligence-assisted optimization, and operations research techniques through an interactive web portal, this system enables fair, conflict-free, and automated invigilation duty allocation for large academic institutions. It demonstrates how modern computational intelligence can simplify complex academic scheduling tasks while reducing administrative effort and ensuring fairness and transparency in duty allocation. Finally, I would like to acknowledge the support and encouragement received during the development of this system. SASTRA University, DAKSH 2026 Team. Vice Chancellor, Dean Piandi. Dean School of Mechanical Engineering. Controller of Examinations. Faculty members of School of Mechanical Engineering. University Examination Committee Team.